Okay, so here we go. We're going to start chapter 7, which has a bunch of easy parts and one little kind of tricky part. But before we start chapter 7, we need to talk about your spring paper. Remember how you wrote a paper in the fall? You're going to write another one. Okay? Now, here's what this one is about. First of all, it's due April 16th. Okay, April 16th. Alright? Hard and fast deadline though, don't be screwing around with it. This one you can't write ahead of time though, because next Wednesday is Ash Wednesday. What happens on Ash Wednesday? Lent starts. What is Lent? Lent is a time when you can sacrifice something, but you can also do something extra. So you make a sacrifice of time by doing something extra. So this is what I want you to think about. I want you to think about a small activity. So it can be something like washing the dishes twice a week. It can be taking your little sibling to his athletic practice every Monday. Something you can do to make someone's life better. So, lots of possibilities. But it's something I want you to be able to do repeatedly. So Lent is 6 weeks. So it's something you should do at least 6 times. You know, once a week, maybe you can do it twice a week, depending on what it is. Help your little sibling with homework. Every Thursday night, I have quality time helping my little brother study spelling, whatever. You know what your family life is. Do something to make someone else's life a little bit easier. Okay, doesn't have to be a big thing. Then your paper will be about, you're gonna tell me what you did, you're gonna tell me how it impacted you, and how it impacted the other person. So, for example, if you decide every Saturday morning, I'm gonna strip the bed, so whatever, every Saturday morning, do the laundry, make them back up again. That would be a wonderful gift to your mom.
Oh, do her bed.
Then you will write about how it impacted you. You know, it was kind of hard. I didn't realize how hard it was. But my mom really appreciated it because she got to spend more time, I don't know, going grocery shopping or, you know, whatever. So do we all understand what the paper is about? Okay, so again, this is nothing you're going to plagiarize, and please don't make it up. This is truly, you're giving a gift during Lent. You're making a sacrifice. And even if you're not Catholic, you can still do something for someone else. You don't have to put it in a religious context if you don't want to, that's fine. But everybody can do something nice for someone else, right? Paper's due April 16th, which is right before Easter. It's just like before. It's 20 points for the paper, 5 points for putting it into Canvas. Paper won't be counted unless it is put into Canvas, so be sure that you do that part of it. And you remember from the first semester, I do read the papers, so I want you to tell me what you did. I want to have happy feelings. Sometimes I cry when I read those because they're so wonderful. What are you doing? So anyhow, everybody's clear. If you have a question about it, I'm going to put the directives into Canvas. I haven't done that yet, but I'll put the prompt or whatever into Canvas for you, but I pretty much just explained it. If you have any question anytime along the way, ask me. Don't wait till April 15th, okay? This is something you're going to be working on during the 6 weeks leading up to it, and then you'll have your paper ready to go. Okay? All right. Now, chapter 7. Here we go. Solve the system. Number 1 and 3 and 6 all say solve the system using substitution. we're gonna solve the system using substitution. Does anybody remember how that works?
I thought I remembered.
I'm gonna do number 1, 3, and 6 first, okay? Who remembers how substitution works? Get one variable by itself. Now, my suggestion is, you can always get, they're not back there, Jack, they're not back there yet. You can always get any variable by itself. You guys need to be in school. You can get one variable by itself. I suggest that you always get the one that's already unattached. So, for example, in our problem, the only variable up there that isn't hooked to something else is that first x. This one has a 2, this one has a 2, this one has a negative. Let's not use any of those, let's use that one. So I'm gonna take that and I'm gonna subtract the 2y. Now, why is it called substitution? Because now I'm going to take this right here and substitute it in for that x. Remember this from freshman year? So 4 minus 2y minus y equals 3. So I get one of my variables by itself, and then that thing gets plugged in place of that variable in the other equation. So then I'll multiply it out. And solve my equation. So I distributed, collected like terms, subtract 8 from both sides, and it looks like y is 1. Does that look okay to everybody? But we remember that we're not done, because we still have to find, well, I got y. I still have to find x, and where do I put it in? Wherever you want. You can put that y in wherever you want. I like to put it in here, because then I don't have to do any messing around. But you can put it in anywhere. Put your 1 back in for y. So it looks like x is 2. And then we'll write our answer as the ordered pair, x comma y, 2 comma 1. Why are we writing it as an ordered pair? These are lines. And if you graphed these lines, guess what they would do? They would cross. And guess where they cross? At the point 2 comma 1. Okay, easy. Look at number 3. Now these two equations are a little bit tougher equations, but the idea is exactly the same. We already have a letter by itself, right? So what do we do? This is number 3. What do? Actually, if I'm doing substitution, I'm gonna take this and plug it in right there.
Yeah.
So x plus 1 squared equals 5. Remember, for substitution, get one letter by itself, and then whatever that one you got by itself, whatever it equals, it gets plugged into the equation. Now, how do I solve this? Take your coat off. Yeah, this is a FOIL. That's going to be a FOIL. So x plus 1 equals 5. That is a FOIL. You have to do what he said. Write out 2 of them and now FOIL them. So here we go. X squared I do? Combine like terms. So I'm gonna have x squared plus 3x's. I'm gonna move that 5 over, so minus 4 equals 0. What do I do with that? Factor it. That's a little quadratic equation, so now I'm gonna factor it. How does that factor? X minus 1 plus 4. Remember what I always tell you to do? Check it, right? If you're unsure, check it, FOIL it back together. What does that mean? That means that x equals 1 or negative 4. I'm not done. I have x1, x is negative 4, but I still need to find my y's. So I'm going to come right back over here. You can go either place, it doesn't matter. I'll get them wherever you want. This time I'm plugging in x's. So if x is 1, then it looks like y will be 2. Excuse me. Thank you. And if x is negative 4, it looks like y will be negative 3. Now you might be wondering why this problem had 2 answers. Remember, a squared equation is a parabola. Remember, quadratic, x squared, that's your parabola. This one is y squared, so this, you don't need to know this, but that parabola looks like that. And then you have this line cutting through it. Do you see why there are 2 answers? The last problem we did was 2 lines. They're only gonna have 1 answer. Oh gosh, sorry about that.
Whoa.
I threw it right at you, sorry.
You just do something.
I did, and it's on video, I'll probably
Yep. Sewer.
get sued. If I'm not here, my video on
Yeah,
it.
she's like,
So, anyway, so that's why this one has 2 answers. Okay, last substitution problem is number 6. Now, take a look at the setup of the equations. I need to get one letter by itself. I'm doing substitution. So I need to get one letter by itself. I think this is your best choice. Would you agree with me? Not your only choice, but your best choice. So x equals 4 plus y. All right. Now I'm going to take this 4 plus y, and I'm going to plug it in for x. Right? Now this is the equation where I got x by itself. You plug into the other equation. So what is that going to say? 2y minus 2 times 4 plus y equals 3. This is getting substituted in place of x, because that's what it equals. Okay? Alright, let's solve that guy. 2y minus 8 minus 2y equals 3. Uh-oh, we have trouble in River City. What happens in that equation? The y's cancel, and what does it end up saying then? Negative 8 equals 3? Is that true? No. What does that mean? No solution. It means no solution. So remember, these 2 are lines. These 2 equations in the problem, there's no squares, they're just lines. If there's no solution, what does that mean about your lines? They're parallel. These 2 lines are parallel. They're not going to cross. Now, let's look at problems 2, 4, and 5. They look exactly the same. The difference is you are told to solve with elimination. I'm sure your Algebra 1 teacher told you this. In the real world, nobody cares how you solve it. Substitution, some people love substitution, some people, I'm an eliminator, I love to eliminate, that's all I ever do if I'm on my own. But in math class, there's going to be a problem on your quiz that says solve using substitution. And then there's going to be a problem that says solve using elimination. So we have to know both methods. Well, how does elimination work? Do you remember? We're doing elimination here. Anybody remember how it works? Okay, Eli says he wants to multiply the bottom equation. And notice I put parentheses around the whole thing because if you're going to multiply, you have to multiply everything in that equation. And he chose 3. I wonder why Eli chose 3. Eli, why did you choose 3? Because if he multiplies by 3, then this guy is a positive 3y. And when I add these equations together, eliminated. That's why we call it elimination. The y's are eliminated. Now the x's are not. There are now 17 x's, and they are equal to 85. I add the equation straight down. So that means, what is that, 5?
5.
X is 5. You aren't done. Please don't stop. You have to now plug in 5 somewhere in one of your equations. I'm going to plug it in the top one. It doesn't matter. Put it in somewhere. But you are plugging it in for x. So I'm going to have 10 minus 3y equals 13. Putting in 5 right here. So negative 3y equals 3, and I got negative 1. Anybody else get negative 1? Solve using elimination. So when you eliminate, you don't get anything by itself. You make a match so that you can cancel it out. One has to be positive and one has to be negative, just like Eli did there. Okay, now number 4 looks scarier, but it works the same way. So take a look at it. What? Okay, so Cam has suggested we multiply the bottom by 3. Will that work? You might have had a different idea, but will his idea work?
Yep.
Oh, shoot, I forgot to take attendance. Yes, go ahead and work on that while I get my attendance in before they call me over to PA. All right, how far did you get? X squared minus 3y squared equals negative 11, and then 6x squared plus 3y squared equals 18. So did you get 7x squared equals 7?
Yep.
So x squared equals 1. Be careful. That means x equals plus or minus 1. Remember, whenever you take the square root, you have to do plus or minus. Alright, then we gotta plug back in and get y. So I'm gonna have two answers. X is either 1 or x is negative 1. So let's plug it back in. I'm gonna plug it in my bottom equation. It doesn't look as scary. So 2 times 1 squared plus y squared equals 6. I'm plugging it in my bottom equation right here. What's 1 squared? Times 2. So y squared equals 4. And y equals plus or minus 2. So if I put in 1, the number 1, I got 2 y's. So I can write it that way, or I can write it as 2 separate points. That's what it is. When I put in 1, I put 1 in, I got 2 different y's. What happens if I put in negative 1? Same thing? Won't it be the same exact thing? Because when you square negative 1, you still get 1? Oh my gosh, how many answers does this problem have? 4. So you can write them together with the plus or minus, you can separate them all, whatever you're comfortable with. The reason we have 4 is, this guy right here is what we call a hyperbola. So he looks like this. And that guy right there is what we call an ellipse. It looks like this. You see why there are 4 points of intersection? Yep, because we have 2 conic sections. One ordered pair can have everything plus or minus? Yeah. Yep. Just recognize that's really 4 ordered pairs. All right, one more. And then 7-1 is finished. This homework will be due on Tuesday. All right, here we go. Oh wait, no, wrong problem. I did number 5. Sorry, number 5. Now remember, you're doing elimination. So what do you think we should do here if we're doing elimination? Look at your equations. Anything bother you about the way they are? Shouldn't we get things lined up so we can add them together? So the top one looks okay. What am I going to do with the bottom one? Add 6y over. If you're going to eliminate, things got to be lined up. All right, so what do you want to multiply by? Top one by, it would have to be negative 2. Remember, you got to have a negative in order to make them cancel. So if we multiply the top one by negative 2, we'll have negative 2x minus 6y negative 16. Remember, they go all the way across. What's going to happen? Now, last time we did this, I can't remember exactly what it was, but it was something like 5 equals 8. And you said, no, 5 doesn't equal 8, no solution. What happens here? What's on this side? 0. What's on this side? Is 0 equals 0? Is that true? Yes. So this one is no answer, and this one is infinitely many answers. Okay? What happens in this problem Don't say all reals is wrong. I'm gonna show you why. What happens in this problem is, if I graphed this line, it would look like that. And then if I graphed this line, it would be right on top of it. They are the same line. So remember when this happened, we had parallel lines? They didn't intersect. When this happens, you have the same line. You see what I'm saying? Most of the time they're gonna cross like this, and you're gonna get an answer. Sometimes they're parallel, sometimes they're the same. Okay? So you're gonna work on that homework next time we have class. We'll have a little practice quiz, and then the time after that, we will have a little substitution elimination quiz, which should be like a snap for you.
Wait, it's gonna be on quarter 3 or 4.
What day will that be? Tuesday? It'll be on quarter 3? No, I don't see you Monday. It'll be Wednesday. Still good. Still good. Be on this quarter. All right, here we go. Now we're gonna start 7-2. Probably, maybe brand new to you, but very, very easy stuff. If you pay attention, learn the rules, and practice, this is very easy stuff. The systems we just solved were systems of 2 equations, 2 unknowns. When systems get bigger than that, a lot of times it's useful to use a matrix to solve that. What is a matrix? Well, in your notes, you see I got some definitions here from vocabulary. So a matrix is a rectangular array of numbers arranged in rows and columns. I say this every year, and kids don't take me seriously. On test day, there will be a little definition section, because there's a lot of new words in this evening. And I promise that one definition you're going to have to write is that. Okay, most of the chapter is about matrices. We need to know what a matrix is. A rectangular array of numbers arranged in rows and columns. So I'm going to show you an example of a matrix. I'm just going to make one up. I'm going to give it a name. I'm going to call it matrix A. There is a rectangle. Would you agree that's a rectangle? And its numbers arranged in rows and columns. These are rows. Think of a bleachers, like the bleachers. Rows go this way. This is a column. Think of the White House. Columns are up and down. So rows are this way, columns are this way. The dimensions of a matrix, just like if you came in here and I said, what are the dimensions of this room? You might say 30 by 40. Those are the dimensions. We do the same thing with a matrix. The dimensions of a matrix are its rows by its columns. Now, that does not mean times. That's a by. Like when you go to the Lowe's and you buy a 2 by 4, that's 2 by 4. Those are its dimensions. So that's what I'm talking about right here. These are dimensions. So how how many rows does my example matrix have? 3 rows. How many columns does it have? It's called a 3 by 2. That is a 3 by 2 matrix. The entries or the elements those are the numbers inside the matrix. So there are 6 entries or 6 elements. Those words are interchanged. I'll usually say entries, that's what I'm most comfortable with. The entries and elements are the numbers inside there. All right, now pay attention. If I want to talk about this particular number right here, if for some reason I want to talk about that number, I would use a lowercase a because this is matrix A. All of the numbers inside matrix A are little a's. Okay, these are all little a's. This is the little a that is in the 3rd row, 1st column. So when I put a 3-1 subscript on that A, this tells me look in matrix A, find the number that is in row 3, column 1. So row 3, column 1, that's this guy right here. Can you tell me what entry is in the 1-2 spot? What number is in the 1-2 spot? Be careful. What does 1-2 mean? 1st row, 2nd column. So 1st row, 2nd column would be 3. Carson, 2-1 is -1 because that's row 2, column 1. Don't ever get your numbers switched around. It's always rows by columns. So whether we're talking about dimensions or the entry subscript, the first number is row, the second number is column. Just remember Roman Catholic, RC, row, column. Okay, always, always. All right. A scalar, that's another important word. Anybody in here take physics and talk about scalars? A scalar, you talk about scalars, right? In physics? Cole? Oh, Jack pointed at you. All right, a scalar is simply a real number. So if you look down to problem 1E, see how it says 2A? 2 is a scalar. It's like a coefficient. It's a number outside the matrix. And then equal matrices. Anybody want to take a wild guess what equal matrices are? Well, equal matrices have 2 qualifications. First of all, they have to have the same dimensions. So if 2 matrices are going to be equal, doesn't it make sense they have to be the same size? I mean, a 3 by 4 can't equal a 5 by 5. They have to be the same size. What is the second thing you think has to be the case if they're going to be equal? Okay, let me just put a couple up here. All right, are they the same size? Yes. Do you think they're equal? No, because why?
Because
Different numbers. So Jack says, hey, if you're gonna be equal, not only do you have to be the same size, but you have to have the same numbers. So let's look at this, Jack. You think those are equal?
yeah.
Actually, they're not.
Different order.
Yeah, exactly. So not only do you have to have the same entries, but they have to be in the same spot. So you have to have the same corresponding entries. And what that means is that if you're going to be equal, the number in this spot has to be the same as the number in that spot. Right now, I know what you're thinking. You're thinking, well, that seems really kind of dumb. But you'll see how we use that fact as we go through the chapter. So these are not equal because even though they're the same size, they don't have the same numbers in the same spots. Okay, you ready to do a little matrix math? Here we go. Number 1A. What are the dimensions of matrix A? 2 by 2. Why 2 by 2? 2 rows and 2 columns. 2 by 2. How about matrix B? 2 by 3. Remember, rows go this way, like the bleachers. Think of the bleachers. How many rows are there in that matrix? 2. Columns are like the White House. They go up and down. How many columns? 3. 2 by 3. All right, 1B. What is the entry in matrix A in the 2-1 spot? 3. What does 2-1 mean? Row 2, column 1. That's a 3. How about in matrix B, the 1-2 spot? 0, because that means first row, second column. Everybody getting that? There'll be a quiz over this sometime soon too. All right, and finally, matrix C, 3-1. There isn't one. There isn't one. Because what does 3-1 mean? Row 3? I don't have a row 3. Trick question. No answer. All right. C says we're going to take matrix A and add it to matrix B. I'm going to tell you it's not possible. That's an impossible problem. No answer. Can't do. Any idea why not? Why they can't be added?
They don't have the same.
They don't have the same dimensions. Guys, if you're going to add or subtract matrices, they have to be the same size. So A and problem C, 1C, A plus B is not possible. Now, do you think A plus C is possible? All right. Yes. We can add these. Does it make sense to you that when I add my 2 by 2 with another 2 by 2, I will come up with a 2 by 2? And how do you think I'm going to get the entries, the numbers inside my 2 by 2? I'm going to take this guy and adding to that guy. So this is a 0. And then I will take this and add it to this. So that's a 3. This and this make 7. And this make negative 4. Adding matrices is very common sense, very logical, very easy. Add corresponding entries. Okay? I calculate what's known as a scalar multiple.
Times
We're
2.
multiplying A by a scalar. What do you think we might do?
Multiply by 2.
Everything by 2. It's like a big distribute problem. So we're gonna have 2, 4, 6, negative 8. I told you, this stuff is easy. You gotta learn the rules, but it's easy. Now, what do you think about 2C minus A? And what does that mean? That means we're gonna take 2 times matrix C and subtract matrix A. Alright, so what's gonna be our first step? Multiply by 2. So that's gonna be negative 2, 2, 8, and 0. And we subtract the same way we add, you guys. So I'm gonna take negative 2 minus 1 and get negative 2 minus 1, negative 3. And then 2 minus 2, 8 minus 3, and watch it, 0 minus negative 4. 4. All right, you good with that one? All right, one more on this page. B minus 2A. No answer. He didn't waste a minute on the problem. He said, there is no way I'm gonna be able to subtract B and A because they aren't the same size. They don't have the same dimensions. Do you see that? You're gonna find on the next page too, there's gonna be problems that aren't possible because of the rules of matrix operations. If you're going to add and subtract, your matrices can be any size, but they have to be the same size. All right, hang on to your hats. Now we're gonna multiply. It multiplies a little bit different. It's easy. You'll get it figured out, but it's a little bit different. So I'm gonna take matrix A, which is 1, 2, 3, negative 4, and I'm gonna multiply it by matrix F, which is negative 1, 5, 3, 0. So I am on problem 2A. It's probably the last one we're gonna get to today. Let's see. So, the rules for multiplication are different. Here are the rules for multiplication. What are the dimensions of this first matrix? How many rows? How many columns? 2 by 2. What are the dimensions of this matrix? 2 by 2.
Okay.
Now, here's the rule. If you are going to multiply these two, the inside two numbers have to match. In other words, the columns of the first must be the same as the rows of the second. All right? So if I had a 5 by 3 and a 3 by 12, I can multiply those. I can't add them, but I can multiply those. The rule for multiplication is, write down your dimensions, these two have to match. Then these two tell you how big your answer is. So inside's matched, so I'm gonna multiply. These outsides tell me my answer is going to be another 2 by 2. If I were doing this, these match, but my answer would be a 5 by 12. Alright, so inside's gotta match. If they match, you can multiply, and the answer you get is going to be the size of the outside ones. Alright, now, here's how we do this. I put blanks in here. Those are not like fractions, right? Those are blanks. I need to figure out what that number is right there. Now, that number, right here where my finger is in row 1, column 1. Agreed? So I am going to circle row 1 and column 1. So this number, the number I'm looking for, is row 1, column 1. Always row and then column. Now I'm gonna write down the numbers in the row. Leave some space there. So 1, 2. And then next to those numbers, I'm going to put the column numbers. So -1, 3. So I started by writing down my 1 and my 2. And then right next to them, I wrote the -1 and the 3. You're gonna multiply those, each pair, and add them up. So this is gonna be -1 plus 6. So the number that goes in this spot is a 5.
She gets to a point.
Now, I'm gonna move over here to this blank. Now, this blank is in row 1, but now I'm in column 2. So I'm still in row 1, so I'm still gonna write down the 1 and the 2. But now I'm pairing it up with 5 and 0. So I multiply each pair and add, and this is also a 5. That's coincidence, guys. There's no pattern here at all. The numbers are totally random. It so happened it came out to be 5. This takes some practice. You'll get it figured out. It just takes some practice. Okay, now I'm down here. Where am I? What is this? This is now row 2, column 1. So row 2, column 1. So write down your row numbers. Pair them up with your column numbers. Multiply each pair and add them. So it looks like, did you get -15?
Yep.
Alright, can you do the last one on your own? Your last one is going to be row 2, column 2. So 3 -4 and 5 0. Did you get 15? Again, there's no pattern. Please don't think there's a pattern.
Oh,
Just random
okay.
numbers. All right. So we have homework due next Tuesday. We'll practice for a quiz on Tuesday, take a quiz on Wednesday. Probably practice for another quiz on Wednesday. Got a lot of quizzes going on.